Okay, how to graph transformations of the log function. Remember that the initial log function, and whatever the base is, I'll just use log base of 2 as an example. So all log functions, when x is 1, the function equals 0. And then when x equals whatever the base is, in this case 2, it's going to be equal to 1. So in the general, it's y equals log base b of x. If x equals b, then it's going to be 1. And remember, the horizontal asymptote of the general function, of the parent function, is just x equals 0. So it's the y-axis is the horizontal asymptote. And it looks like that. It should be approaching but never reaching that 0. So something like that. It's hard to draw that approaching but never equaling. So transformations. Let me try to zoom out. I guess like that. Now I can make more room. I'm going to do some transformations just to see how they work. And these are going to be the important things. When I do these transformations, the important things are going to be whatever makes what I'm taking the logarithm of equal to the base, and then whatever makes whatever I'm taking the logarithm of equal to 1, because then that's the 0 point. All right, so let's check out 1 here, or I will check out 1. I don't like to say let's. Y equals log base 7 of x plus 3 minus 2. First of all, the horizontal, it's not a horizontal, did I say horizontal asymptote? First of all, it's a vertical asymptote. Vertical asymptote goes up and down, not side to side. Vertical asymptote, VA, the vertical asymptote is x equals minus 3. It shifts left and right, opposite of sign. So the normal vertical asymptote is x equals 0. This one shifts to the left, 3, x equals minus 3. The domain is that asymptote minus 3 to infinity. The range is always negative infinity to infinity. Notice the curvy bracket here at minus 3. It's an asymptote. It will never reach it. And then to graph some points, I want the point that makes x plus 3, I'm in my dead spot on my screen, equal to 1. So I want x plus 3 equal 1. And then x plus 3 equals 7, equal to the base. Because at the base, log base 7 of 7 is 1. Log base b of b is 1. So I set whatever I'm taking the log of, x plus 3 equals 1. That's what this is supposed to say, x plus 3. There's a dead spot on my screen. X plus 3 equals 1, and x plus 3 equals 7. Well, if x plus 3 equals 1, x is 1 minus 3 is minus 2. And if x plus 3 equals 7, x equals 4. And then plug those into the equation and see what the y value is. Negative 2 plus 3 is 1. Log base 7 of 1 is 0. 0 minus 2 is minus 2. 4 plus 3 is 7. Log base 7 of 7 is 1. 1 minus 2 is minus 1. Now I've got enough to graph this. I know the vertical asymptote is x is negative 3. I know 2 points, negative 2, and 4, 1, and I know the general shape of this thing. So good enough. The general shape is like this. So that's it. There's the graph. I will do another one, and this time I will put a negative in front of it, and this is going to flip it. So this is y equals negative log. And I'll do x minus 2 plus 2. So now instead of looking like this, it's going to look like this. It's going to flip it. let me find my vertical asymptote. Normally the vertical asymptote of the parent function is 0. This is 2 to the right, so this is x equal 2. The domain is 2 to infinity. The range, negative infinity to infinity. I forgot to put a base up here. Let's say this is log base 3. It's log base 3. I forgot to put my base. So I want x minus 2 to equal 1. And to get that, I need an x value of, well, negative 2, add 2 to both sides, x equal 3. Now let me plug 3 in there. 3 minus 2 is 1. The log of 1 is 0. Negative 0 is 0, plus 2 is 2. Then I want it to equal 3. X minus 2 equals the base, equal 3. I will add 2 to both sides. X is 5. So when x is 5, 5 minus 2 is 3. Log base 3 of 3 is 1. Negative 1. 2 minus 1 is 1. So now I've got my 2 points. And it's 3, 2. And 5. And 1. And I've got my vertical asymptote is at x equal 2. And I might want to plot one more here because now it's crossing the x-axis. So I want to see what happens when y equals 0. 0 equals negative log x minus 2 plus 2. Negative 2 equals negative log x minus 2. It was log base 3. Keep forgetting to write the base. And so negative, I'll divide both sides by negative 1, 2 equals log base 3 of x minus 2. Now I can do the hook. 3 squared equals x minus 2. 9 equals x minus 2. X equals 11. So it crosses the x-axis at 11. I just, when it's an upside down one, when it's got a negative in front of the log, I try to find out where it crosses the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I was a little bit off when I originally drew it. It's got to be something like that. Okay, so that's why I should have done that first. So there it is. Now what if there's a factor in front of it? Let me try this one. Y equals 1/2 log base 2 of x plus 2 minus 3. Well, same thing. Vertical asymptote, it's usually 0. That will be 2 to the left. So x equals minus 2. The domain, negative 2 to infinity. And the range, negative infinity to infinity. I will plot some points. I just need to plot 2 points. And the points I will plot will make x plus 2 equal 1 and x plus 2 equal the base, which is 2. So to make x plus 2 equal 1, x equals negative 1. To make x plus 2 equal 2, x equal 0. So I've got those 2 points. I'll put this down here. And when x is negative 1, negative 1 plus 2 is 1. Log base 2 of 1 is 0. 1/2 of 0 is 0. And minus 3. And now 0. 0 plus 2 is 2. Log base 2 of 2 is 1. 1/2 of 1 is 1/2. Minus 3 is minus 2.5. So 0 minus 2.5. Now I've got everything I need. I've got my vertical asymptote. X is minus 2. I've got my, well, I guess I should always really figure out where it crosses the x-axis. Always set y equals 0 and calculate that point as well. So I got negative 1, negative 3. down there. And I've got 0, negative 2.5. Something like that. And now I will set y equals 0. Should have been doing this for all of them. 0, oh, that's my dead spot. 0. Hold on, let me pull this function down here. Zero equals 1/2 log base 2 of x plus 2 minus 3. I will add 3 to both sides. 3 equals 1/2 log base 2 of x plus 2. I'm going to multiply both sides by 2. 6 equals log base 2 of x plus 2. And I can write that as an exponential. 2 to the 6th power equals x plus 2. 2 to the 6th, 2 times 2 is 4, 8, 16, 32, 64. 64 equals x plus 2. X equals 62. So it's going to cross the x-axis at 62. So that's way off this graph. So somewhere way up there. I don't know, that doesn't even draw it in perspective, but it's way far away that it's going to cross the x-axis. All right, so that's what I do. I find the vertical asymptote by doing this x shift. Then I set that, whatever I'm taking the logarithm of, set it equal to the base and find out what x is equal to, and then plug that into the equation and get the y value. Whatever I'm taking the log of, set it equal to 1. Find that value of x, plug it into the equation, get the y value, and then set y equals 0 and solve for x to find where it crosses the x-axis. And that's it. I will do one more. And let's try this. I will just try negative log base 3 of x plus 2 plus 2. Vertical asymptote equals, well, normally it's x equals 0. This is a shift of 2 to the left. X equals minus 2 is a vertical asymptote. Domain, negative 2 to infinity. Range, negative infinity to infinity. And then my table, x and y. And I want x plus 2 equals 1, and x plus 2 equals the base, which in this case is 3. X plus 2 equals 1. Subtract 2 from both sides. X is negative 1. Negative 1 plus 2 is 1. Log base 3 of 1 is 0. Negative 0 is 0. Plus 2 is 2. And then if x plus 2 equal 3, then x equal 3 minus 2 is 1. 1 plus 2 is 3. Log base 3 of 3 is 1. Negative 1 plus 2 is 1. Then I will set, technically this is y equals, I will set y equals 0 to see if I can find where it crosses the x-axis. Negative log base 3 of x plus 2 plus 2. I will make this a little bit bigger so I have more room. I will subtract 2 from both sides. Negative 2 equals negative log base 3 of x plus 2. Divide both sides by the negative. 2 equals log base 3 of x plus 2. And then this is going to be 3 squared equals x plus 2. 9 equals x plus 2. 9 minus 2 is 7. X equals 7. So when x equals 7, y equals 0. So now I can, and this is negative, so it's going to look like this. And the vertical asymptote is x is minus 2. Like that. I've got negative 1, 2, and 1, 1. And 7, 0, 2, 3, 4, 5, 6, 7. That's where it crosses there. Remember, this is the upside down log. I gotta scroll my screen over. And so, trying to hit those points exactly. Bam, crosses the x-axis. Okay, I got a little bit above the points, but something like that. That's what that one looks like. Okay, so that's logging transformations of the log function, or graphing transformations of the log function.